Derivatives of inverse trigonometric functions. See this table. The derivatives of the functions sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x and cosec inverse x are shown here in this table. In the second row you can see the derivatives. Sin inverse x, the derivative is root of 1 upon root of 1 minus x square, and there is one condition given, mod x less than 1, that is a fundamental condition for sin inverse x's domain. Then you have the second function cos inverse x, whose derivative is minus 1 upon root of 1 minus x square. Derivative of tan inverse x is 1 upon 1 plus x square. Derivative of cot inverse x. These two derivatives can be seen together. See, tan inverse x is derivative 1 upon 1 plus x square, and derivative of cot inverse x is minus 1 upon 1 plus x square. Derivatives of sec inverse x and cosec inverse x, they are also similar, just a sign difference. Derivative of sec inverse x 1 upon x root of x square minus 1, and that of cosec inverse x is minus 1 upon x root of x square minus 1. So for a while you can just ignore the conditions below these derivatives, like derivative of sin inverse x written there, and then the condition mod x less than 1 is written. You can remember these conditions, but important thing is remember the derivatives. So remember them pairwise. Derivative of sin inverse x and cos inverse x, you can see the two derivatives. Leave aside these conditions mod x less than 1 for a while. As a beginner we can ignore them for a while. Then derivative of tan inverse x, cot inverse x, these two. Then the derivatives of sec inverse x and cosec inverse x. So like this you can remember this table, and we shall try to find these derivatives in simple steps. Let's start with the first function, y is equal to sin inverse x. Its derivative has to be found out. So what we do is we write y is equal to sin inverse x as x is equal to sin y. You can write it anytime like that. X is equal to sin y, which means now we can differentiate x is equal to sin y with respect to y. Remember this, differentiating with respect to y. That means d by dy of left side, d by dy of left side is d by dy of x, and d by dy of right side, which is d by dy of sin y. Now what is d by dy of sin y? D by dy of sin y is equal to cos y. So dx by dy is equal to cos of y. Now this cos of y is written as root of 1 minus sin square y using the fundamental trigonometric identity. Now you will understand why we wrote root of 1 minus sin square y in place of cos y. Because see, sin y is x. In the second step you can see from the top, x is equal to sin y. So we wanted to write the derivative dx by dy in terms of x. So we wrote cos y as root of 1 minus sin square y. That means root of 1 minus, what is sin y? Sin y is x in the second step. So you can write that as root of 1 minus x square. Now use the formula dy by dx is equal to 1 upon dx by dy. This is the rule for differentiation of inverse functions. So in this, so lastly you can write that as 1 upon root of 1 minus x square, because dx by dy was root of 1 minus x square. So we wrote it in the last step. So the derivative you should remember for sin inverse x, y is equal to sin inverse x as derivative. Derivative of y is equal to sin inverse x is 1 upon root of 1 minus x square. Remember these steps. Take y is equal to sin inverse x in the beginning as it is given to us, then write that as x is equal to sin y, then differentiate it with respect to y. So you get dx by dy is equal to d by dy of sin y, which is dx by dy is cos y. Cos y is written as root of 1 minus sin square y. That means root of 1 minus x square. So dx by dy found. Then write dy by dx as 1 upon dx by dy and finish it as dy by dx is equal to root of 1 minus x square. In the same manner, we can find the derivative of cos inverse x also, and these two, sin inverse x and cos inverse x, are similar kind of derivatives, so we can manage that on our own, but I shall show you cos inverse x also. So here it is, y is equal to cos inverse x. How do you write it? As x equal to x equal to x equal to cos inverse, x equal to cos of y, then differentiating with respect to y. So what do you expect in the next step? Dx by dy is equal to d by dy of cos y, which will be dx by dy equal to d by dy of cos y, which will be minus sin y. Now how do you write minus sin y? Dx by dy has to be written in terms of x. So what is your x? X is cos y. X is cos y. So you can write this sin y as root of 1 minus cos square y. So what do we get? Root of 1 minus cos square y in place of sin y. So dx by dy is equal to minus root of 1 minus cos square y, which will be minus root of, in the last step, what do you fill up? Minus root of 1 minus cos square y means cos y is x, so cos square y will be x square. So you get this y is equal to cos inverse x, differentiated later on, but before that, y is equal to cos inverse x is written as x is equal to cos y. Then we differentiate with respect to y, get dx by dy minus sin y. Dx by dy is minus root of 1 minus cos square y. Dx by dy is minus root of 1 minus x square, because cos y is x in this case. And then finally writing dy by dx as 1 upon dx by dy, which is minus 1 upon root of 1 minus x square. Now let us see d by dx of tan inverse x. So take y is equal to tan inverse x. You as usual write x is equal to tan y. Then dx by dy means differentiating with respect to y. Differentiating with respect to y gives you d by dy of tan y, which is sec square y. Now you have to write sec square y in terms of tan y, because you have to write dx by dy in terms of x, and x is tan y. So write this sec square y as 1 plus tan square y, which is 1 plus x square, because x is tan y. In the second step you can write, see this x is equal to tan y written here, tan y is replaced by x square. So dy by dx is 1 upon dx by dy in the end, so which will be 1 upon whatever dx by dy you got, which is 1 upon 1 plus x square will be the next. So what you get, dy by dx is 1 upon 1 plus x square. So see, from the beginning x is equal to tan y, because y was tan inverse x. Then we differentiated with respect to y, get dx by dy is sec square y, which is 1 plus tan square y, which is 1 plus x square, and finally dy by dx is 1 upon 1 plus x square. Similarly, you can find out derivative of cot inverse x as, you know this, it's 1 upon 1 plus x square with negative sign. So y is equal to cot inverse x, dy by dx is equal to minus 1 upon 1 plus x square. Let's see y is equal to sec inverse x. So you can find this derivative by writing x is equal to sec y, differentiating with respect to y gives dx by dy is sec y tan y. Here you have to change tan y, because you're going to write this dx by dy in terms of x. So what is x? Dx by dy is equal to sec y tan y, which is sec y into, write that tan y as root of sec square y minus 1, so that you can write the whole dx by dy in terms of x. X is sec y. So writing dx by dy as x into root of x square minus 1, because sec y is x. Sec y is x. So you write dx by dy as x root of x square minus 1, and then write dx by dy by dx as 1 upon dx by dy, which is 1 upon x root of x square minus 1. See, y is equal to sec inverse x, written as x is equal to sec y in the beginning. Then differentiating with respect to y, we get dx by dy is sec y tan y. Now we don't have any problem with sec y because sec y is x. What is the term which we should consider is tan y. Tan y is root of sec square y minus 1. Now this expression sec y into root of sec square y minus 1 easily is written as x into root of x square minus 1 because x is sec y. So then dy by dx is 1 upon x root of x square minus 1. And then similarly you can find the derivative of cosec inverse x, which is just a sign difference there. Dy by dx is minus 1 upon x root of x square minus 1. You can do it at home. So in this manner we have seen these derivatives of 6 inverse trigonometric functions. Remember them. You can leave these conditions for a while and just remember the derivatives. Sin inverse x, cos inverse x, they have the same derivatives, similar kind of derivatives, not same but just sign difference. Then a pair tan inverse x, cot inverse x, then another pair sec inverse x and cosec inverse x. So in this manner you can remember these derivatives so that we can use them in the examples.